In a country, the percentage of coffee drinkers is equal to the percentage of tea drinkers. Half of the people who drink coffee also drink tea and vice versa. If 16% of the population do not drink either of the two beverages, what percentage of the population drink both coffee and tea? So this kind of problem is best solved by the Venn diagram approach. And here we typically start with this rectangle that kind of represents the entire population of the universe. And then in this particular case, let's represent the percentage of coffee drinkers with this circle labeled as C. And we draw another similar circle labeled T that represents the percentage of tea drinkers. And by the problem, these two percentages are equal. Now, the area of overlap between the two circles, so that represents the percentage of people who drink both coffee and tea. Now, the area of the circle C, the circle of coffee drinkers, that lies outside this common or overlapping area represents the percentage of people who drink only coffee but not tea. And similarly, the area of the circle T that lies outside this overlapping area, that represents the percentage of people who drink only tea but no coffee. Now, in the problem, it's given that the percentage of coffee drinkers is equal to the percentage of tea drinkers, so that will be C is equal to T. It's also given that half of the people who drink coffee also drink tea and vice versa. So that really refers to this overlapping area C and T, so both coffee and tea drinkers, which is equal to half of the coffee drinkers, right? C by 2. And that will be the same as half of the tea drinkers because the percentage of coffee drinkers and tea drinkers are equal. Now, we have this common area, and that's C by 2. So, the area of the circle C that's outside this overlapping area that represents only coffee drinkers who do not drink any tea, so only C, no tea. So, that will be the whole circle is C minus this common overlapping area, which is C by 2. So, it's C minus C by 2, and that's equal to C by 2. And in the same way, the area of the circle T that's outside the overlapping area, that is also equal to T minus C by 2. And since in this case T and C are equal, we can replace T by C. So it's C minus C by 2, and that also comes as C by 2. So we have these three regions in that circular area where each area is equal to C by 2. Now, what about the area that lies outside the circle? So that's the shaded area that lies outside the circles. So that does not include any coffee drinker or any tea drinker. So that basically represents the population or the percentage of the population that do not drink either coffee or tea. And going by the problem, that percentage is 16%. So now, if we consider only the area which is not shaded, which is the circular areas, so if we add C by 2, C by 2 and C by 2, the three C by 2s, that should be equal to the whole percentage of population, which is 100%, minus the shaded area. which is 16%. And that would be equal to 84. So from this, it's easy to solve for C. C becomes 56. And then the problem asks for the percentage of the population that drink both coffee and tea. So that will be the C and T. And we have, in the previous step, that one listed as C by 2. So we just half C, and the population or the percentage of coffee and tea drinkers is 28. So that's the percentage that people who drink both coffee and tea.